Hi, this is Dr. Mercola, and today I'm here with Clint Ober, and we're here to demonstrate the science behind a really powerful principle called grounding or earthing. And it's like many things in life, you can't feel these, so you really need some objective documentation to really demonstrate what's going on here. And to do that, we've put together some really easily available tools, such as a low voltage electronic meter that you can pick up pretty much anywhere, and Clint will describe it in more detail, for under $10. So you can see this for yourself. We just put it together in one centralized location so you can see that. But if you don't believe it, you can replicate this and perform this observation for your own analysis. So thank you, Clint, for coming and joining us and helping us understand how this whole science of grounding and earthing is, the principles are based on.
Well, thanks for the opportunity. It's a real pleasure to be here and share this. Never sure where to start, but I think the first thing we'll try to explain is the EMFs. Everybody's heard about them. Most people don't quite understand them. And to a large degree, people are somewhat in denial that they exist because they don't know how to deal with them.
Yeah.
And
it's somewhat like smoking. You know, you're not going to, most people aren't going to have a negative impact initially. It's only over long-term exposure that you have a problem.
Right. So I think what we'll do is start with the main thing. We have a lamp here that's plugged in, and the thing that everybody needs.
This is just a conventional halogen lamp, not necessarily the healthiest lamp from a light perspective around, but nevertheless an example of something that's plugged in that isn't an appliance that we're typically exposed to.
We could use a toaster, a hairdryer, a lamp, anything, any type of lamp, and as long as they're plugged in, they're going to radiate an electric field. And most people are unaware that these exist, and what makes them, what they're most unaware of, if I can have you hold your hand flat out here, this one. Okay. You're sitting next to the lamp. Put this hand closer to the lamp. So you can see that your body is a conductor. You are an antenna. Mm-hmm. And so if you're ungrounded in free space, meaning...
And I'm not grounded now.
Yeah, if you're ungrounded in free space meaning you're above the ground, then these electric fields are going to be attracted to your body, and there's lines of force that try to pull you into compliance. So it creates a surface charge on your body, a voltage.
And this is not new. This is actually well established and recognized within many industries, like the medical field and surgery. A surgeon's not going to operate on you in the operating room unless you're grounded.
That's correct.
For these principles, and also electronics.
Yeah, anybody who works on software chips in the factories, they have to be grounded so that they don't build up any static electricity or charges on their body, so when they touch something that it'll harm the software or blow the chip.
And this for the very reasons that we're describing now, that you can easily demonstrate yourself if you don't believe it.
Right. And grounding, or grounding the body to prevent these charges goes back to the dynamite industry in the very beginning and the gasoline industry, mm-hmm. because if you have a static spark and you're unloading gasoline, you'll have an explosion.
And you're dead.
If you have a spark in a fireworks factory or a dynamite factory, it's up in smoke. Mm-hmm. So it's a very real phenomena, and huge amounts of money are spent annually protecting people from, protecting equipment, and just protecting environments and so on. So anyhow, the main thing is this is what's called a low voltage electric field detector. They have high voltage, which the low voltage will work best for what we're trying to identify here. These are sold in all the hardware stores, any electronics store, and they usually run anywhere from $6 to $10, $12. So, but it's really nothing more than to demonstrate that the reason these exist is for an electrician or somebody working with electrical wiring. They can go into the wall and identify where the wires are, and before they drill holes, or to make sure that a wire is actually, energized. And so that's all they're really for, is just to identify that an electric field exists.
Yeah, but it's an interesting gadget to have for yourself to show and demonstrate, and
Right.
it's really inexpensive. It's only under
Right.
$10.
So the main thing that what we wanted to do next is, I mean, this is the field, and so what we want to do is measure the effects of the field on the human body. So what I'm going to ask you to do is put, let's say, this hand here. I'm just going to put an electrode patch here so we have a good connection. And you can just be comfortable. And what we're doing here is we're going to set, this is a regular conventional voltmeter. So one thing that's important to know about these fields is its proximity. The closer you are to an electrical device or an electrical cord, the more charge that's going to be created on your body. If you move away, it drops to near zero. So what we've done here, just to illustrate the effect of grounding, because we were talking about it earlier with the dynamite and so on, is this particular mat here is grounded. It's similar to something that is commonly used in the electrical environment, but this is grounded to the earth. And so I'm going to ask Joe to, if you're watching the voltage here, to reach over and put your other hand right here. And we'll see that the voltage dropped from, I think, a little over 1 volt down to 2 thousandths of a volt.
Essentially insignificant. At what point does the voltage level become significant biologically? I mean, there's a range. But.
You know, there's many different thoughts on it. To me, 0 is perfect because that's where we would be in nature.
If you're out in a forest or at the ocean, you're going to be pretty close to 0.
You're going to be 0.
Yeah.
There'll be noise on background noise on the earth. But in a living environment, if you can get this down below, to me, 100 millivolts, 20 millivolts.
Okay. So 1 is 1,000 millivolts.
Yeah, 1 volt is 1,000 millivolts. In the average home,
and that's my normal exposure just sitting here is
Yes.
1,000 millivolts.
Yeah,
and up to 2,000 when I go to the.
Yeah, if you were in a typical home, where I've done most of my measurements is in the bedroom, because you've got the lamps, and then the thing that's really important to know is during sleep is probably when people are more exposed to electric fields than any other time. Earth's energy, the surface of the Earth has a negative surface charge. As soon as you plug the ground wire in to the Earth, to a ground rod or to the electrical earth ground, then Earth's energy comes up this wire.
Electrons.
Electrons and its electric field come up this wire, and they energize this pad. They energize the housing of your computer, the housing of a refrigerator, or any device that is grounded. So basically what happens, Earth's energy comes up, and the Earth is infinitely large. So as soon as you touch this, then your body becomes energized by the Earth. You are now electrified by the Earth rather than the electric field. The electric, your body
dwarfs the electric fields.
When you're in free space, then your body is infinitely small compared to the Earth. And so these electric fields can perturb electrons in your body, create voltage, create charge on your body.
This may not seem like a big issue, but what you may not appreciate is that our bodies are, for a large part, an electrical component to it.
Yeah.
And that's the way that we work.
Right.
If there was no electricity, we'd be dead.
That's true. That's how when you pronounce somebody dead, when there's
That's
no
a flat line.
there's no electricity left. So, but the point is that when you touch this, you become electrically one and the same as the Earth. You are the Earth. The Earth is infinitely large, and it can give up energy, electrons, and whatever, and it actually pushes and prevents.
Against these types of fields.
Yeah, so it removes the charge from your body.
So even though I'm exposed, actually, you see a bit more when I'm exposed closer to it.
Yeah.
But you would expect it because this is twice as big.
Yeah, it's all proximity. So, but anyhow, we'll get into that more in one of the other sessions.